Now that we've talked about some of the causes, we're going to talk about some of the mitigation techniques. And notice the word mitigation is used here. These are not necessarily solutions, they are mitigations. First, we're going to talk about queue manager clusters, which provide workload balancing across queue managers. This works very well with shared queues to distribute message puts across the queue managers in a queue sharing group. Then we'll talk about some of the techniques we've seen used to help with connection skewing mitigation, gateway queue managers being the first one, and then redriving connections once they have been made into a queue sharing group is the second. Finally, we're going to finish up with CPSM mitigation techniques that we've seen used and are encouraging some people to look at currently. Queue manager clustering. When messages are not bound to a specific queue manager, that is, they're put with the option that says bind not fixed, the messages are generally routed evenly across the receiving queue managers. So on the slides that you will see, the first put of a message to a cluster defined, to the same cluster defined queue, is the black arrows. The green arrows show the second message, so they are very evenly distributed. That means internally that the puts will take place for the first messages that were put from all of the queue managers within the cluster to queue manager QMG3. The second one will all go to QMG4. Then if we have put to waiting getter turned on, we have all the processing of local favoritism, we will get a very even distribution of the workload. This is often the simplest technique to use. So from a connection skewing mitigation perspective, we're going to talk about two mitigation techniques, gateway queue managers and redriving those connections once they have been made. When we don't have any gateway queue managers, or when external queue managers or clients are passing work directly into application hosting queue managers, then every attempt, of course, is made to process work locally. Talked about that at length before. It's to keep the path length down to make things more efficient in the overall environment. Environments that use gateway queue managers into the queue sharing group often eliminate this connection skewing problem simply in the way they function and operate. Now, the mitigation technique is relatively simple. What happens is that you have a couple of queue managers in the queue sharing group that are dedicated to accepting connections from external queue managers, usually distributed, and client connections, so that the queue managers that are handling the connections are not handling any of the application workload. We often see this technique used when customers want to isolate the connection queue managers to make them extremely available and to absorb the workload of the logging for persistent messages that are put. Those types of requests. It means that the logging that takes place happens in those gateway queue managers, not in the application queue managers. In fact, the first example we had of this mitigation technique working, the customer had no idea about the workload skewing that they were preventing. They were doing it primarily to isolate the logging, but it worked very well in their environment for this, in addition to keeping all that logging isolated. The second technique that we've seen a couple of customers look at implementing recently is redriving connections. When a queue manager is unavailable, inbound connections can get skewed to other queue managers within the queue sharing group. This is normal availability processing, and we don't want to do anything to hurt that, because the whole idea here is that if I have a queue manager or an LPAR anywhere in my Plex go down, the workload can be absorbed without impact, or with as little impact as possible, on the other queue managers in the queue sharing group. But once a connection is live and active, there's never an attempt made to balance the connections. Once the connection is physically made, it's going to stay there unless it is redriven. So when we talk about redriving connections, What the customers are doing in this case is that they are actually executing little batch jobs that run on the distributed queue managers periodically to disconnect or to stop the channel and then to restart the channel. That will drive the connection back through the Sysplex distributor, and the connections might be more evenly distributed. What we have seen in practice in this is that a number of customers will run these batch type files prior to their busiest time of day. So for example, if your busiest time of day is 10 a.m. when your branch is open, you might choose to have these particular little tasks run every day at, say, 8 a.m. to redrive the connections so that you'll get an even distribution of connections into your queue sharing group.
In the final part of this presentation, Lynn will talk about mitigation techniques that use CPSM. Please join us for that.